Okay, so today we're going to look at notes for 3.1, which is graphing linear inequalities. It says sketch the graph of the following linear inequalities using intercepts. All right, so we're going to use our intercepts, which means we're going to set x equal to 0 and solve for y, and then set y equal to 0 and solve for x. So let's create a little chart. You're going to put x is 0 and y is 0. Okay, now you're going to rewrite the equation, and you're going to have 2 times 0 plus y is greater than 6. And you get y is greater than 6. So now you're going to rewrite the equation, and you're going to put 0 in place of y. So you're going to have 2x plus 0 is greater than 6. So now you're going to have 2x is greater than 6 and x is greater than 3. All right, so your points are going to be 0, 6, and 3, 0. Okay, so let's put our values over here, 0, 6, and 3, 0. Okay, so now let's graph those points. You're going to have 1, 2, 3, and then 0, 6, 1, 2, 3, 4, 5, 6. Okay, now connect those lines, draw your line out, connect those points. Okay, so since it's an inequality, oh, and that's it, this is a dotted line. Okay. Because our inequality is greater than. And if it's greater than or less than, you should have a dotted line. And if you have greater than or equal to, or less than or equal to, you have a solid line. So this one's going to be dotted. So, okay. All right, so now let's create a test point of 0, 0. You're going to rewrite your equation. You're going to put 0 in for x, 0 in for y. And you get 0 is greater than 6. Is that true? Is that a true statement? 0 greater than 6? No, it's false. All right, so when we plugged in 0, 0, we got false. So therefore, your test point is 0, 0 is false. That means you're going to shade the opposite way of the point. Okay, from the line. So if it would have been true, we would shade towards the point, on the side of the point. But since it's false, we're going to shade on the other side of the line. Okay, and that's it. So now let's look at number 2. Let's do the same thing. We have x and y. 0, 0. 3 times 0 minus 2y is less than 18. Negative 2y is less than 18. And you would get y is greater than negative 9. So your sign flips because you're dividing by a negative. So y is negative 9. Now you're going to rewrite it, and you're going to put 0 in for y. 3x is less than 18. And you're going to get x is less than 6. Okay, so 6. So your points are going to be 1, 2, 3, 4, 5, 6, 0, and 0, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now then, it's going to be a dotted line. Okay, now we need to do our test point. Of 0, 0. You're going to get 3 times 0 minus 2y, which is 0. It's less than 18. So we put zeros in for x and y, and you're going to get 0 is less than 18. And that is true. So this test point right here of 0, 0 is true. So that means we are going to shade towards the point, 0, 0. Like this, can you see? Okay. Okay, last one. We're going to do an example that doesn't have a y. So number 4 on the notes. X is greater than or equal to negative 3. So there is no y here, so you don't have to find your intercepts. If you have x, an equation with just x or just y, you don't have to solve for your intercepts. Okay, you just need to solve for the variable and graph it. So for here, this would be x is negative 3. So we don't have to do anything other than come over here and go find x is negative 3. 1, 2, 3. And it's a vertical line. Okay, so now put your test point in, which is 0, 0. So you'll have 0 is greater than or equal to negative 3, which is true. 0 is greater than negative 3. So your test point of 0, 0 is true, so that means you're going to shade toward that point 0, 0. And we drew, and the line was not dotted here because our sign is greater than or equal to. And if you have or equal to, it's a solid line. Okay, when you don't have the or equal to is when it's dotted. Okay. All right.